Hello viewers, welcome to my channel Flex Master. Today we are going to discuss in the chapter number 22 corrugated board packaging, continuing from the previous chapter. So let's start. Chapter number 22 corrugated board packaging and manufacturing process for corrugated board. A corrugating machine consists of several steps shown in the figure 1. This involves unwinding and conditioning of liners, medium, corrugation of medium to create the flutes, bonding the fluted medium to the liners, drying the finished board, cutting and scoring the board. And you see this machine drawing, and here this liner goes and single face board, bridge store, then its travel, belt conveyor, heated table, double face board, adhesive application, secondary liner from here, and fluting medium. All right, and these are the rules. So single facer stations create the fluted medium and bond it to a single liner or face, usually the inside liner, before passing it on to double backer stations which add the second outer liner. At the beginning of the process, both medium and liner are preconditioned with steam to make them pliable for processing. The medium is fluted by being passed between large rolls with a surface pattern matching the required flute geometry. Older machines use fingers to hold the fluted medium whilst it was being processed, but modern machines use vacuum pressure to hold the medium in place, reducing potential indentations and improving compression strength. And adhesive is that then applied to the flute tips. The liner is pressed against the tips where a combination of heat and pressure bonds the two surface together. Typically, greater pressure is used at this stage to ensure a strong bond, resulting in the glue lines potentially showing through. This is why this liner is usually on the inside of the finished case. The single-phase material, which is still flexible at this point, is sent to a conveyor mechanism known as a bridge, where it is draped in an overlapping wave pattern as it travels to the double backer station. The purpose of the bridge is to separate the single phaser and double backer stations, allowing for different operating speeds and reel changes. At the double backer station, adhesive is applied to the flute tips on the other side of the medium and the outer line is glued on. Corrugators normally have more than one single facer unit, which allows additionally plies to be combined at the double backer to create double or triple wall boards. The fully assembled corrugated board with liners on both sides is now stiffed. It is passed between two long flat belts or final heat setting and cooling. The edges are then trimmed and the finished board is slit to width and cut to length as required. At the same time as slitting to the correct width, the machines will also score along the planned flaps for folding. The finishing sheets are then stacked ready for assembly. There is a range of scoring patterns depending on the container design. Starting with scores along the top and bottom flap, the reverse scores, 3-point or offset point-to-point scores are used where the case flaps will be folded in one direction to close the container. Manufacturing process of corrugated, it's when flaps need to be first bent outside. These bend profiles may produce an uneven break when heavy materials are used. In such instance, a 5-point score is preferred. See in the figure number 2, 5 points. Then these are the profiles of 3-point left and 5 points right scoring wheels. Here complete showing the typical scored and slotted sheet tolerance for B and C fluid single wall. So it is detailed as can be sent to you if you write me the email. The resulting joint can be glued, taped, stapled, or stitching. Gluing is relatively simple as fast operation when offers a strong joint. It is the most common joining technique. Double gluing can be used to enforce corners. The data in figure number 3 to 8 in the coming slides provide typically scored sheets and manufactured glued joint tolerances for B and C fluid single wall cases. Tapping, stapling, and stitching are slower, semi-automatic operations. Wire stitching is commonly used on triple wall constructions and where treatments such as waxing prohibited normal gluing. And tapping is used for oversized cases not able to put through a gluer and for application where the overlap of the normal glue tab is undesirable. Pressure sensitive and heat activated tapes have increasingly replaced gum tapes since they are easier to apply. Tapes can be also be used in the board manufacture for reinforcing containers. Tapes can be used to provide handhold reinforcement for carrying. They can also include easy opening tier features and some RRP packs use the tape to turn the container into a tray to make shelf stacking easier. Application of these tapes can be only run in the machine direction of the corrugator. More complex design, example those needing angled or curved cuts or creases required a die cutter which can be a flatbed press which gives greater accuracy or a rotary press which is faster. The crease is pressed into the board using a scoring rule. The die can be specially designed to incorporate special features. Die-cut designs are correspondingly more expensive than the regular slotted containers. One disadvantage is that die cutting can flatten corrugated flutes, resulting in a loss of compression strength. Table 4 here showing the gap tolerance for B and C fluid single wall case. Measuring gap is minimum B fluid 1.5, C fluid 1.5, ideal 4.5, 5.5 for C fluid, maximum 7.5 millimeter and 9.5 millimeter for C fluid. And here in table 5, you see the gap tolerance for out of square and fishtail. This is called fishtail. U-joint configuration. The maximum allowable difference is 3 mm. Table 6, identifying overlap. Any amount of overlap is unacceptable here. Table 7, length and width of glue tabs. Minimum acceptable width is 27 mm. Tabs extending more than 1.5 millimeter beyond horizontal male scores are unacceptable since they are hinder proper step folding and cause out of square cases. Common cases of style. This style full overlap slotted container, and this is all floor flaps meeting slotted container. Here half slotted container with or without cover. Style folder again, style folder third. Then different types of corrugated box board design. There are three main basic types of containers: regular slotted containers, die-cut containers, multi-component designs. Regular slotted containers are containers in which all scores and cuts are in the straight lines only in the machine and cross direction. See in the figure 9. It's a regular slotted container, RCS blank. So all these scores are completely straight. These containers are easy to manufacture on standard machinery. The manufacturer simply sets the slotter and folder gluers to the required dimensions. Basic case design can be made with or without top flaps. Variations are primarily differences in how the flaps are cut. A typical RCS, which is regular slotted container, has end flaps the same width as the side flaps. The results in an economical rectangular master sheet and a case where the end flap do not meet in the center. And we stop here for chapter number 22nd, and we continue for the same topic in the next chapter, chapter number 23. So corrugated board packaging. Thank you. So friends, we have completed the chapter number 22 for corrugated board packaging, and we will continue for our next video for chapter number 23, the same subject. And we request you kindly subscribe the channel, comment and like, and don't forget to press the bell icon. Thank you very much.